Hello students, how are you all? We will continue with the same chapter, that is force and pressure, and today I will finish this chapter. So we have already discussed pressure exerted by gases in the previous class. So today we will discuss about atmospheric pressure. What is atmosphere? You know that the air surrounding us is called as atmosphere. Now this air is gas, and you know gas is a matter, and matter is what? Which has mass and which occupies space. So air is gas, so air also has mass, and this air, it consists of large number of particles. Okay, so air has mass, air has weight, and air, it exerts its weight on all the living organisms. Okay, so please underline, the layer of air above the earth is called as atmosphere. The air in our atmosphere extends up to about 300 kilometers above the surface of the earth. The atmosphere contains a tremendous amount of air. Air has weight, so the atmosphere consisting tremendous amount of air has enormous weight. Now you know atmosphere, the weight of the atmosphere is too much. It has an enormous weight. Weight of the atmosphere exerts a pressure on the surface of the earth that I just told you, and this pressure which is exerted by atmosphere, okay, that is called as atmospheric pressure. So atmospheric pressure is the air pressure which is exerted by the weight of the air present in the atmosphere. In other words, atmospheric pressure is due to the weight of the air. Yes, so I told you this thing. Air, what is atmosphere? Atmosphere is the air surrounding us, and it has weight. Okay, so weight, you know here the weight is equivalent to force, and this atmosphere, it exerts the force. Okay, it exerts the weight on all the living organisms, and you know the force per unit area, or the weight which is equivalent to force which is exerted per unit area is pressure. Okay, and it's also called as air pressure or the atmospheric pressure, and it exerts this, you know. Now please, magnitude of atmospheric pressure. Now you know pressure is force per unit area. Now please see in your books carefully. Just see here in this diagram, page 205. Now here, this one, just see here, this one you take as, consider as unit area, and let this be a air column. Okay, and here the air is filled. Okay, see here. Now if we imagine a unit area of the earth's surface and a very tall column filled with air standing over it. So just consider this as a unit area, and let this be a tall column filled with air over this unit area. Understood or no? And you know the area is measured in meter square. Okay, therefore we can also say that now see here. Now see here, this is the column, and what is this? This is the air particles here. I told you air consists of large number of particles, so these are the particles of the air. Now all these particles of the air is exerting force on this unit area, force, and this is unit area, so this is force per unit area. So this is pressure, so you can say all these particles are exerting pressure, and these particles, how much force they are exerting, that is equivalent to its weight. Okay, so more air, more weight, less air, less weight. So this is atmospheric pressure. Okay, please underline. We can also say that atmospheric pressure is equal to the weight of air present in the very tall column of air standing over 1 meter square area of the earth. So that's what I told you. Okay, on the surface of the air, the atmospheric pressure is maximum at the sea level. Why it is maximum at the sea level? Because of the air, the amount of air is more. So if the amount of air is more, it will exert more weight, and you know here the weight is equal to force. So the force which is exerted per unit area will be more, pressure will be more. So on the surface of the earth, the atmospheric pressure is maximum at the sea level. This is because the column of the air above us is tallest at the sea level. Okay, at the sea level, the amount of air is more. Okay, the atmospheric pressure on the surface of the earth is this much atmosphere, this much kilopascals, 101, my God, which is equivalent to the weight of 10 elephants pressing on each square meter area. Thus the magnitude of atmospheric pressure is very large. But as we go up in the atmosphere from the surface of the earth, the atmospheric pressure goes on decreasing. Now see, suppose if this is the sea level, so much of pressure is exerted. So the pressure, atmospheric pressure is more. But when we go up, okay, from this is the sea level. Now when we go up, okay, suppose we go up, so till here, suppose we have reached here, so here only this much of air will exert a weight, or this much of air will exert a force, this much of air will not exert force. So the weight of the air, or you can say the amount of air, will decrease. The weight of the air will also decrease, and weight of the air is the force. So force per unit area will decrease and the pressure will also decrease. Please see here. As we go up in the atmosphere from the surface of the earth, the atmospheric pressure goes on decreasing. This is because as we go up in the atmosphere, the weight of the air above us goes on decreasing. So the atmospheric pressure on the top of the high mountain will be much less than its weight. Okay, so if you here, the atmospheric pressure will be more because more air, but as we go up, the atmospheric pressure decreases. If we reach here, let us say this is the mountain, if we reach here, so only this much weight is exerted by the air. So this weight, which is equal to the force per unit area, will be less, pressure will be less. Now here in SI unit of pressure is Pascal, but for atmospheric pressure it is generally measured in millimeters of mercury. The atmospheric pressure on the surface of the earth is 760 mm of mercury. These are some of the activities based on the atmospheric pressure. You can read the activities, I will explain you. Now you take this glass, fill it with water and cover it with the cardboard. Tightly cover it with the cardboard so that no air is present inside the glass, and you just tilt it. The cardboard will not fall down due to the weight of the water. Why? Because from here below the pressure is exerted, air, it exerts the upward pressure, and which tightly binds this cardboard with the glass, and this pressure of the air is more than that the earth. You hold it little bit high, don't touch the ground, then it will fall because the air pressure will decrease. Understood or no? So that is why it does not fall. Now you see this one, this experiment. These are the two hemisphere. This is the knob of the hemisphere. Here you can see there is a pipe, side pipe. This is to create a vacuum. Okay, you can see here. It is okay. This pipe, it is sideway, which is connected to the vacuum pump. So what will happen if the air is present? That it will, whole of the air will drain out. Okay, now what happens? Now these two hemispheres, they can be tightly pressed. Okay, they can be joined tightly. Now when the air is present inside these two hemispheres, when the two hemispheres are joined together and when the air is present, then they can be easily separated. But if the air is not present and these two are joined together, and from this pipe the whole of the air is removed, then what will happen? These two cannot be separated. For example, here you can see in this arrangement, inside there is no air, okay, and it is not possible to separate these two hemispheres if it is pulled by so many horses. How many horses are given here? Where are the horses? Just you can read 8 horses maybe on both the sides. It is pulled, okay, and yes, 8 horses. But these two hemispheres cannot be separated because the pressure, atmosphere, air is exerting a pressure, and it is too much of pressure that it cannot be, two hemispheres cannot be separated. Now if that is the case, then air is exerting pressure on us also, and it is exerting lot of pressure on us, and in that case so we should have been crushed, but it doesn't happen. Why? Because, underline, if the pressure due to atmosphere is so great, then why we are not crushed by it? Because in our body there is a liquid called blood, and this blood, it flows in the blood vessels to reach the cells, and this blood also exerts pressure. Blood also has pressure. So the pressure, which is called as blood pressure. So the atmospheric pressure and the blood pressure is same. The arrangement is in such a fine that the atmospheric pressure and the blood pressure, they balance each other, and we don't even feel the atmospheric pressure. We don't feel any discomfort. Okay. Our blood itself exerts a pressure called blood pressure, which is slightly greater than the atmospheric pressure. It's slightly, very little greater, not more, because in that case then the organs will start bleeding. Okay, understood? So here the blood pressure is very, very slightly greater than the atmospheric pressure. Since the atmospheric pressure acting on our body from outside is balanced by the blood pressure acting from inside. Okay, both the atmospheric pressure is acting from outside, and inside there is a blood pressure. So both of them, they balance each other, and we do not get crushed. We do not even feel. Actually, the atmospheric pressure is so finely balanced by our blood pressure that we do not feel any discomfort. Okay, so in our body there is a blood pressure of the blood. Outside there is atmospheric pressure. Blood pressure is slightly greater, but they balance each other. Okay, and they balance each other slightly greater, or you can say almost equal only, you can say. They balance each other, and we do not feel atmospheric pressure, or we do not get crushed. We do not feel the existence of atmospheric pressure at all. Okay, effects of flow. Now the atmospheric pressure is maximum on the surface of the earth, but when we go high altitudes, the high mountains, the atmospheric pressure decreases. Now students, you know what happens? So at high altitudes, the atmospheric pressure becomes much less than the blood pressure. When you go in the mountain, or when you go in higher altitude, the atmospheric pressure becomes less and the blood pressure becomes more. Okay, since our blood is at a slight higher pressure at the mountains than outside pressure, therefore some of the blood vessels in our body burst, and nose bleeding takes place at high altitude, because blood pressure is more. The pressure of the blood is more. It is under pressure. It flows under pressure, and some of the vessels burst, and through the nose, which is opening nose starts bleeding. Thus nose bleeding usually occur in those persons who trek to high mountains. Okay, now what are the applications of atmospheric pressure in everyday life? It is very easy. Drinking straw. This is a glass full with water, or any cold drink, you can say Coca-Cola, or any cold drink, or any juice also. Now when you suck you know that you suck with the straw. This is the straw. You suck the juice with the straw. When you do so, there is no air in it, because then this pipe, what is present? The juice is present, or the water is present, and atmosphere, it is exerting a pressure on this juice from outside, and because of the pressure it moves upward. Understood? Now even you can say in the syringe also, if this is the syringe, this is what? This is the nozzle, and this is the pump. Okay, this is the piston. Now you know this piston can be moved out, it can be moved in also. If any medicine has to be taken, then it is moved outside, and if any medicine is to be injected, it is moved inside. Now what happens when it is moved out? What happens? Air pressure decreases. When it is moved out, what happens? This much air, suppose it is inside, so this much is occupied by the air, this much space is occupied by the air. When it is pulled out, the space is increased, the air particles, they move freely, they occupy more space, so the pressure is reduced or no? So when it is moved out, it is pulled out. When this piston is pulled out, the space is increased and the air pressure decreases, because I have told you in the last class also, the particles, they move freely, and the air pressure, or you can say air pressure decreases. But you can see from outside also, air is exerting pressure on this liquid, and the outside pressure becomes more, and the medicine or the liquid, it goes inside the syringe. Understood? So same is with the dropper also. Please read this dropper one on your own. So I'll discuss question answers with you. Some of the question answers I have already given to you for homework. So remaining question answers I'll discuss with you. And there are some questions which are repeated. Those questions we will not do. Okay. Now you just see question number 9. Okay, when a plastic pen is rubbed in dry hair, it attracts tiny pieces of paper. Which force is involved in this process? So here the force involved is electrostatic force. Question number 10. A small device pull iron nails from a distance. Which type of force is involved in this process? Magnetic force. Question number 11. Which force can be used to gather iron pins scattered on the floor? So it's again magnetic force. Question number 12. Name the force which always opposes motion, that is frictional force. Question number 13. Which force make a rolling ball stop on its own? It's frictional force. Question number 14. An inflated balloon. This one I have given you for homework. So still inflated balloon was pressed against a wall. After it has been rubbed with a piece of synthetic cloth, it was found that the balloon stick to the wall. What force might be responsible for the attraction between the balloon and the wall? So it's electrostatic force. After rubbing it with a piece of synthetic cloth, balloon got charged and then it got attracted by the wall. So it's electrostatic force. Question number 15. What name is given to the force acting on a unit area of object? It's pressure. Question number 16. Name the quantity whose one of the unit is Pascal. Again pressure. Question number 17. What conclusion do you get from the observation that a fountain of water is created at the leaking joint of pipes of the main water supply line? Open page number 203. Please write the answers in your copies. So 203 you can mark from here. I hope you can see the fountain of water from the leaking pipes of water supply pipeline till here, till water carrying pipes. Try to write in your own words. Next question. What type of pressure is involved in filling a liquid in the syringe? So that is atmospheric pressure. Question number 19. What substance present in a body balances the atmospheric pressure acting on us? It is written what substance present in our body. So that is blood. Okay. Blood pressure, it balances the atmospheric pressure. Okay. Question number 20. Where will the atmospheric pressure be greater? At a ground level or at the top of the high mountain? So it will be higher at the ground level. Question number 21 and 22. It's homework. You will do this two questions in homework. Question number 23. What makes a balloon get inflated when air is filled in it? It's air pressure or the pressure of the air in the balloon. Okay. Question number 24. Name the substance whose weight produces atmospheric pressure. So air. Okay. Now students, in a balloon it's air pressure. Okay, because when we fill air in the balloon, then it gets inflated. So that air, contains particles which exerts pressure against the wall of the balloon, and due to which the balloon gets inflated. So that is air pressure. It's not atmospheric pressure. Atmospheric pressure is also the air pressure, but the balloon gets inflated only due to the air which is filled inside the balloon. Okay. So I told you the difference. It's a closed container. Balloon is considered as a closed container. Question number 25. Where is the pressure greater? 10 meters below the surface of the sea or 20 meters below the surface of the sea? So it is greater at 20 meters below the surface of the sea, because here the depth is more. And as the depth increases, the pressure also increases, because the amount of water or the amount of matter increases, and thereby the weight increases, and this weight is equivalent to the force, as you know, acting per unit area. So force also increases. Question number 26. What force acting on an area of 0.5 meters square will produce a pressure of 500 pascals? First, very important thing is this, students, you have to see that the unit should be same. Either the unit should be SI units or either it should be in a other system, that is the CGS system. If units are not same, then you have to convert it into same units. Now like area, SI unit of area is meter square. Okay, but if it is given in centimeter square, then you have to convert that centimeter square into meter square. So that is very, very important. Okay, now the formula of pressure is equal to force upon area. So here they are asking the force. Okay, what are they asking? What force acting on an area? Okay, so force, what will be force? Force will be pressure into area. So what is the pressure here? Pressure of 500 Pascal is produced. Okay, and and area is 0.5 meter square. Okay, now here you can see the area is 0.5. So here the area is less. Pressure is in a unit area, no? So it should be okay. Now force they are asking. Okay, anyway, we'll discuss this later on. So what will be the pressure here? You know how to calculate this? 50 into 5, it is 250. What I will write here? Newton, because the unit of pressure is force is Newton. Okay, so this is the force. So you can check also. It's very easy. Pressure is equal to force upon area. So here the force is 250 Newton. Area is 0.5, and you will get the pressure of 500 pascals. Okay, this will go up. So this will go up. How you will write? If you simplify it more, 2500 by 5, you will get 500 pascals. Okay. Can a liquid exert pressure upward? Yes. Can a liquid exert pressure sideways? Yes. Okay. So this all we have done. Short answer questions. So in short answer questions, please see question number 33. In a tug of war, when two teams are pulling a rope, a stage comes when a rope does not move to either side at all. What can you say about the magnitude and direction of the forces being applied to the rope by the two teams at this stage? So here what happens? Here, what will happen in the tug when two teams are pulling the rope? A stage comes when the rope does not move to either side at all. Why the rope does not move to either side? Here, the magnitude of the force is 0, because on both the sides the rope is pulled, and here there is no direction. Okay, so that is the answer. Question number 35. What is force? State various effects of force. You know what is force? Page 190. What is force? Force is mass per unit area. Sorry, what is force? It is a push or a pull. 190 page. Please open 190 page. Here you can see. Page 190. State the various effects of force. So you know force is a push or a pull, and on page 190 you can see these various effects of force. That force can make a stationary object. Force can move a stationary object. Force can change the speed. Force can stop a moving object. Force can change the direction of a moving object. Okay, so these are the effects of the force. I hope it's clear to everyone. So now just see next question here. State one example where force moves a stationary object. Question number 36. Okay, so this one and question number 37, this one already we have discussed many times. Okay, so you can leave this question or you can write the answer here in the book also, one word answer only, but this question we have done before also many times. Question number 39. These are some examples. Just see question number 40. Name various type of forces. You know what are the various type of forces? That is magnetic force, frictional force, gravitational force. Okay. Now question number 41. Whatever questions I am marking or whatever questions I am discussing, please write those questions in your books, in your copies also. Okay, because other questions, some questions they are repeated. Now what is a muscular? Name various type of force. This we have done. What is a muscular force? So please open page number 192. You can see here what is a muscular force. All of you see on page 192. So please underline here the force exerted by muscles of the body is called as the muscular force. Okay, both human beings and animals exert muscular force to work. So the human beings exert muscular force for performing various day-to-day activities like this. Okay, so this is a muscular force, and muscular force is a contact force. So please mark till where you will mark here, pressing the objects. Okay, so please mark till pressing the objects. Give an example of muscular force. Again open page 192. So here there are so many examples are given and you can write any one example. Okay, Now, which of the following are non-contact forces? This is very easy. Which of the following are non-contact? Magnetic force is not a contact force, frictional force, non-contact gravitational force, and electrostatic forces. These are the non-contact forces. Okay, now question number 43, you can do this one on your own. It's very easy. Question number 44, what is a rubber circle? That one you can read from page 208. Okay, now question number 46, question number 45, why do mountaineers usually suffer from nose bleeding at high altitudes? Open page 206. So why mountaineers they suffer from nose bleeding? Please see here. Please open page 206 and mark the answer from here. At high altitude, the atmospheric pressure becomes much less than our blood pressure. Since our blood is at a higher pressure than outside pressure, therefore some of the blood vessels in the body burst and nose bleeding takes place at higher altitude. Okay, so please write the answer. You can mark the answer. Describe one activity to show the existence of atmospheric pressure. 205. Here you can see page 205. You can write this activity or you can read this activity given on page 205. Okay, and the question is describe one activity to show. See here, describe one activity, question number 46. So the answer is on page 205. You can write that activity, or if you want you can read also. But if you want to write, please write in your own words. Explain why water comes out more slowly than the upstairs tap than the similar tap downstairs. Because in the upstairs tap the pressure is less as compared to downstairs tap. What is question 48? What is meant by gravitational force? Give it's one example. So here page 197. So gravitational force of gravity is what? It is a force which is exerted by the earth. 197. Open page 197 first of all of you. So you can write here, the force with which the earth pulls the object towards it is called as force of gravity. So force of gravity is a gravitational force. Now the difference is this, student. Gravitational force is that force which exists between the objects. It can be any object. As I told you that all the objects, they attract each other by force, and that is called as gravitational force or the gravitational pull. Now the gravitational force of earth is called as force of gravity. It is actually the force with which the earth pulls the object towards it. Okay, so you can mark from here till here, and there are so many examples. You can write any one example. Okay, now calculate the pressure when a force of 200 Newton is exerted on an area of this and this. Now you see Newton is SI unit, meter is also the SI unit. So you only have to calculate the pressure. So you can use the formula pressure is equal to force upon area. So first in A, pressure is equal to force upon area. Force is 200 Newton. So simple. Pressure is equal to force upon area. This is A. So what is the pressure force? Force is 200 Newton. In first case the area is 10. So pressure will be 20 pascals. Okay. In second case the area is 5. So what will be the pressure? Pressure will be more or less? Pressure will be more. See here, pressure is equal to force upon area. Now if area is less, okay, I will just first do it. Pressure is equal to force is 200 Newton, and in the second case the area is 5. This is B part. So what you will get? 40 pascals. Now you see here the pressure is double than this. So because you see the area is less, pressure is more. Here area is more, pressure is less. Okay, here the area is 10. This is the pressure, and here the area has decreased. So pressure has increased twice. Understood or no? So what does it mean? If I am writing 20 pascals is the pressure here, where it is gone? Here 20 pascals is the pressure. What does it mean? It means per unit area how much pressure is acting? 20 pascal is acting. Understood or no? The force acting per unit area is 20. Understood? Now, okay, this all we have done. Which force do the animals apply while moving, chewing, doing? This is the muscular force. Which force is responsible for raising our body here? When this is electrostatic force. Okay. So this question number 59, explain why porters place a thick round piece of cloth on their heads. This one you can read. Okay, it's given in the example. You can read this one and write any one practical application of magnetic force that you can see from the book. It's given there. There are many applications are given. You know that toys, there are certain toys, magnetic toys, there are certain stickers which stick to some of the iron objects or the steel objects like refrigerator and all, because they have the magnet in it. So you can write any one. Now what is long answer type question? What is meant by contact force? Explained with example. Please open page 192 here. You can mark the answer from here. A force which can be exerted by an object on another object. This is contact force. And what are the examples? Muscular force and frictional force. Next is what is a non-contact force. Open page 194 for that. 194. You can see the answer is given here. A force which can be exerted by an object on another object from a distance. You can write till gravitational force. Okay. Now next is name the quantity whose unit is Newton. Sorry, this one here. Here, define frictional force. Okay, define frictional force. This one, open page 193. So you can mark from here. The force which always opposes the motion of one body over another is called as the frictional force or friction. The frictional force acts between the two surfaces which are in contact with each other. So frictional force is a contact force. Okay. Next question. Explain why frictional force. This one just now we have done. So question number B you can leave. Explain why magnetic force is said to be a non-contact force. Open page 194 for question number 62 C part. And why magnetic force is a non-contact force. So you can write from here. Since the magnet can exert its magnetic force on iron objects from a distance even without touching it, therefore magnetic force is a non-contact force. Understood? So you can write this question answer. Define pressure. What is the relation between pressure, force and area? State the units in which the pressure is measured. So 198 page number. Here you can write, see 198. Pressure is the force. Here pressure is the force acting on unit area of the object. To obtain the value of this, after this you write this formula. Okay, and for the units you can write this. 1 Pascal is equal to 1 Newton per meter square, or 1 Pascal is equal to 1 Newton per meter square. Explain why school bags are provided with with white straps to carry bag. Its answer is given on page 199. You can just read it and try to write in your own words. What is atmospheric pressure? What are the causes of atmospheric pressure? Open page 205. What is the atmospheric pressure? So you can write from here. Here atmospheric pressure is the air pressure which is exerted by the weight of the air present in the atmosphere. Okay, so that is the atmospheric pressure. Okay. Why are our bodies not crushed by large pressure exerted by atmosphere? 206. Because the blood pressure and the atmospheric pressure, they balance each other. Okay. So here you can write why our bodies are not crushed. That answer. See, please open page 206. You can write here from here. Since the, I hope you can see here. Since the atmospheric pressure acting on a body from outside is balanced by the blood pressure acting from inside, we do not get crushed. Okay, so you will write till here only. Why our body? Okay, explain why atmospheric pressure decreases as we go higher up in the Earth's surface. page 205. Why atmospheric pressure decreases? So this one you can write from here. As we go up in the atmosphere from the surface of the earth, the atmospheric pressure goes on decreasing, because as we go up in the atmosphere, the weight of the air above us goes on decreasing, okay, right till base. How do the pressure on this one, question number 65A, page 201, you have to write an activity. So for that you can write this activity. Okay, if you can read, or you better read this activity. Okay, explain why the walls of a dam are thicker near the bottom, page 201. Here you can see the walls of a dam is made thicker at the bottom till reservoir of dam. Okay, so multiple choice questions and all we have done. HOTS we can discuss later on. So I have finished question and answers, and in the next class I will start with friction. Okay students, thank you students, have a nice